I had a lot of fun delivering my sessions back in Bangalore last year, and I'm really looking forward to another exciting day in Delhi. So, what's next for cloud? That's the theme for my session today. And I'm going to walk you through certain trends that are evolving, that are emerging, which are making cloud the de facto platform for running the next generation applications. So I often get asked by my customers, has cloud hit stagnation? Because back in 2010, it was revolutionary to launch a virtual machine with a single click and then scale your application by launching additional VMs. From there to where we are today, there has been a significant progress, and a lot of businesses are moving to the cloud. But is cloud just about a set of virtual machines and some blobs of storage followed by some networking? Is that all what is called as cloud? And if that is what is the definition of cloud, are we hitting a glass ceiling that is making cloud stagnate in its progress? Well, I don't want to answer that right now, but I want to come back and revisit this question towards the end of my presentation. But it's very interesting. I have been fortunate enough to track this phenomenon from a very close proximity for the last 8-9 years. So we are at a very interesting juncture where initially cloud was all about running applications, running existing applications. So cloud was run existing applications. From there to where we are is very different. So today there are applications and workloads that are designed exclusively for the cloud. So it is no more cloud trying to be compatible with applications and workloads, but it is time for us to think about applications and workloads that are designed to take advantage of the cloud. So let's see some of those aspects that are being designed for the cloud and what defines the next generation of cloud. So I'm sure most of you heard these jargons like containers, containers as a service, serverless computing, functions as a service, industrial Internet of Things, blockchain. What do they really mean, and how are they aligned with the cloud that we are familiar with, and how do they drive the next set of customers, next generation of applications that will take us to the next level in terms of experiences, in terms of business models, in terms of productivity, right? So let's touch upon some of these trends that would define what's next for the cloud. So I cannot finish this presentation without talking about containers. A lot of analysts believe that containers are the new virtual machines, and it is true to a large extent. So this company called Docker, which started off pretty much as a PaaS company back in late 2000s, has evolved into the de facto container platform, and Docker is extremely popular among developers. And along with that, the container revolution has been caught up by various other companies like Google, Microsoft, which is bringing containers to Windows, Red Hat, which obviously has a stake in the operating system market, and followed by Canonical, which is very popular with developers through Ubuntu, and traditional companies like VMware. And there are emerging startups like CoreOS. So all these companies have one thing in common. They are driving the container revolution. So containers are going to be the next generation of infrastructure. DigitalOcean internally uses a lot of containers and container orchestration, and now it's going to be made available to customers in the form of open source software. So containers are lightweight, they are much more portable, they are much more performant than virtual machines, and most of you would be writing your web applications, front ends, and various other components packaged as containers and deployed as microservices. So going forward, you will see a lot of traction for containers. And just like virtual machines are orchestrated through infrastructure as a service and delivered through IaaS, we're going to see a new model for managing containers, and obviously that is called containers as a service, or CaaS. and developers will take advantage of this by writing highly modular, highly scalable, highly composable applications that are managed by CAS. Some of the choices you have are Mesosphere's DCOS, or Data Center Operating System, or Kubernetes, which is managed by the Cloud Native Computing Foundation or Linux Foundation. Then there are other tools by Docker. And the best thing is you are not really confined or locked into one specific implementation. This is completely open source, and you are free to run containers as a service on any infrastructure of your choice, including DigitalOcean. All you need is a set of virtual machines. So containers are not going to replace virtual machines, but they heavily complement virtual machines by giving you an ultimate scalability layer to run your stateless services to start with and eventually stateful. So containers are the new VMs in terms of designing and deploying applications, and they are going to take cloud to the next level. Obviously, this is not a hands-on tech session. I cannot demonstrate some of these technologies like Kubernetes or DCOS, but if you are a developer and if you want to stay current, I would strongly recommend you to learn containers and understand what they really mean to your applications. So this is going to be the new paradigm for computing. For a long time, we have experienced computing through physical machines or bare metal machines or virtual machines. But going forward, computing will be delivered by containers. So it's going to be a very key technology, both in the cloud as well as on premises. And parallelly, there is another technology that is becoming extremely popular. It's called serverless computing, also known as function as a service. If containers enable developers to write what are called as microservices, functions as a service, it goes a level below and enables something like a nano service, where a developer is expected to write one function at a time, which doesn't do anything beyond one task, and they deploy multiple functions, and later on they connect the dots across multiple functions and they orchestrate this application as a composable set of functions. So you need a new set of tools, platforms to run your nano services written as functions, one function at a time. So there are many open source technologies that are going to power this new paradigm. For example, there is a company called Iron.io, which has been a serverless company for a long time. They are now creating an open source environment called Iron Functions that is extremely portable, extremely lightweight, based on containers, and enables developers to deploy nano services based on functions. Similarly, other companies like Platform 9, a Seattle-based company, is also creating a serverless platform on top of Kubernetes. And IBM has donated a very powerful technology called OpenWhisk to Apache, and you can run Apache OpenWhisk as your serverless computing platform anywhere in the cloud or even in the on-premises environment. So these set of tools and technologies help you embrace the evolving paradigm of serverless computing. This may be something very new, but if you have been familiar with AWS Lambda or Azure Functions, you are already into serverless computing. But the fundamental difference between the set of tools that I am talking about versus what is available is you don't get locked into one platform and one technology. You can use this layer as an extremely portable serverless computing platform in any environment. So on the compute side, we have containers taking over, and then we have serverless computing or functions as a service. On the business side, there is going to be a new trend which is actually like wildfire among financial institutions, and that is called blockchain. So blockchain is like internet. It is primarily a connected, distributed digital ledger where once a record is written, it can never be modified. And to maintain that, you need a very large footprint of infrastructure providers. You need massive compute power to actually calculate the digital key that is going to be associated with every transaction. And this is going to be the next generation digital ledger, not just meant for banking or financial firms, but anything that requires an immutable set of records that need to be maintained. So going forward, blockchain is going to become the de facto for maintaining various immutable records. By immutable, what I mean is there are a set of records that can never be modified. For example, your educational certificates, your experience certificates, and even your land records. So they cannot be modified. And to just draw a parallel, when you buy a property or sell a property, I'm sure most of you would have seen a set of linked documents with your registration copy. So those linked documents are some kind of an evidence that the property has been handed over from one party to the other. Now imagine bringing the same technology to cloud and making every record immutable and trackable. So this is powering the next generation currency, pretty much like Bitcoin. And there are two open source projects that are going to drive the blockchain phenomenon. They are called Hyperledger, which is backed by IBM, and there is another alliance called Ethereum, and this is backed by Microsoft. Both of them are open source projects, and you can implement blockchain by running them on your favorite infrastructure. And blockchain is going to be the next big thing in maintaining digital ledgers. It is not just meant for financial institutions, but things like Aadhaar, things like our government records, all of them are going to move into blockchain. So this is going to be a very, very important use case at cloud. Another example of how new use cases are evolving to take advantage of the emerging cloud architecture. This is my favorite. What's going to drive cloud to take the cloud to the next level is obviously industrial Internet of Things. So IoT is the latest buzzword. Now in India, across the world, there are many startups, there are many established manufacturing automobile companies. Everyone is investing in Internet of Things. Why now? Now, what is really driving IoT and why it is seeing such a traction at this point? So everything, including the elevators that we use, are powered with microcontrollers and sensors and variety of electronics that are capable of generating data. And that data has been so huge and humongous that we could never capture that and store it with our existing infrastructure. And it's not just about storing this data generated by the electronics and the devices and the microcontrollers, it's also the computing power that's needed to process that. And corporate data centers and enterprise data centers have never been sufficiently powered to take advantage of the data that we are capturing from these equipment and devices, and we didn't have enough storage to deal with them. Thanks to cloud, we literally have unlimited storage and abundant computing power. Now we are able to capture the minute details coming from these sensors, move that to the cloud, and use the compute power available to us to process that and generate actionable insights. So whether it is GE running a medical healthcare related connected environment, or Bosch that is actually trying to revolutionize the manufacturing segment, or Ford or BMW that are trying to build connected cars, all of them are going to stream the data and move the data to the cloud, where it is going to be captured, processed, analyzed, queried, and going to be visualized by a variety of decision makers. So cloud is going to become the backbone of industrial Internet of Things. This is going to be the next big thing in cloud, and companies like GE are already bringing their expertise of managing industrial environments through technology. For example, GE has a platform called Predix, which is built again on an open source platform called Cloud Foundry. And Eclipse it's a foundation, and most of us are familiar with the Eclipse IDE. The same foundation is now investing in a set of open source tools called Eclipse IoT. So you can take any of those open source technologies or open source tools and run industrial IoT backends in the cloud. And this is not similar to running a web application that is spanning a bunch of VMs. This requires heavy lifting in the cloud, dealing with tremendous storage capabilities, tremendous computing algorithms, which will bring capabilities like remote monitoring and predictive analytics. So before a machine dies, the IoT software will actually tell the product owner that the machine is going to die, and he can take preventive measures. That is actually called predictive analytics or predictive maintenance. That is going to be a very, very important aspect of cloud. So IoT is going to be the platform as a service or IoT PaaS, and that's going to be a layer on top of cloud. So this is one of the next big things when it comes to cloud, and you will see many companies building platform as a service based on open source IoT offerings. Then comes machine learning, the buzzword of the industry. There is not a single technology article, not a single technology discussion, and an earnings call that doesn't touch upon machine learning and artificial intelligence. And both these terms are pretty much like cloud in its early days. Everyone hears about them, but no one knows what exactly it is, right? But going forward, we'll see machine learning pretty much becoming a part and parcel of everything that we do, from your mobile apps to desktop apps to cloud to even televisions and wearables. And cloud is going to be the power behind machine learning. So let me spend a bit of time explaining you what I mean by that. Going back to my IoT slide, I was talking about capabilities of acquiring data, right? So we have various machines, equipments, microcontrollers, sensors, and we are capturing huge data sets and a lot of data points. Typically, you will end up writing programs that will have a set of rules, right? For example, an if condition to find out if the sensor data is going beyond a threshold. And maybe if the temperature or the pressure is going beyond a specific threshold, you will call another function that will basically inform one of the stakeholders saying this machine might go down. But machine learning is all about making computers learn by themselves based on historical data. So as a developer, you're not going to write a set of if conditions or switch case statements, but you will use a variety of mathematical algorithms that are already available to you, and you will apply your existing data that is collected from a variety of sources, and you will pass the mathematical formulae or the algorithms through your huge data sets. And in that process, you are going to fine-tune these algorithms to make these programs learn with accuracy. So basically, you are enabling machines to learn based on existing data, and cloud is going to help you create that with a lot of precision. So machine learning is not as simple as applying a function to an existing data point. Before you get to that, you need to try a variety of algorithms created by data scientists and mathematicians, and you need to turn on a lot of knobs, drag some sliders, switch on and switch off some buttons to get to a point where your algorithm is highly tuned and works with precision for your set of data points. And to do that kind of computation on petabytes of data, you need solid computing power and tremendous storage capabilities. Where do you get that from? Obviously, it's going to be from the cloud. So cloud is going to power machine learning by enabling you to move petabytes of data and use underlying raw compute power to fine-tune your algorithms to evolve what is called as a model. So once you create a machine learning model, it is ready to take production data or the live data coming from your sensors and your existing data sources, and it can predict what it really means. But before we get there, we need to do a lot of heavy lifting, a lot of groundwork, and that's what is going to be done on the cloud. And how do you really fine-tune your algorithms to evolve models? Well, there are some set of frameworks, again, open source frameworks, coming from companies with decades of research experience. Companies like Google, for example, Google has open source something called TensorFlow, which is actually a deep learning and a machine learning platform which can give you the ability to create your custom machine learning models. Same thing with Microsoft, which has open sourced something called Cognitive Toolkit, which was earlier called CNTK. Then there are Then there is Paddle, which is another framework and a platform coming from the Chinese giant Baidu. And MXNet is another open source deep learning platform where Amazon is throwing its weight. And this is going to be another framework for you to implement machine learning. And Theano is another such open source deep learning and machine learning platform. So all of these new platforms require a lot of computing power. For example, these algorithms, they need to go beyond existing CPUs. They need general purpose processing capabilities through GPUs. So companies like NVIDIA are heavily investing in the next generation of GPU that can do massively parallel processing. While CPUs are designed for high performance, low latency execution of your code, GPUs are designed to deal with massive parallelism. So when you are executing a machine learning algorithm or a function, you need to deal with a lot of data points parallelly to evolve at a specific model. And they are going to be driven by the GPUs. And cloud is going to power those VMs that not only give you high memory and high computing power, but also GPUs. So you take containers that are going to run the machine learning algorithms, which are going to be run on these custom-made GPU-driven instances on the cloud, and your data sets are going to be stored on the object storage and the block storage, which is again based on SSD, and that environment gives you precisely what you need. And in the next 4 or 5 years, we're going to see a lot of traction for machine learning in the cloud. This is the next generation use case for cloud. And we're also going to experience the transformation of big data into fast data. Most of us are familiar with big data, but big data is about collecting and storing historical data and making sense out of that. But with the current connectivity and with the current capabilities, the requirements are slowly moving towards making data more real time. So if big data is all about collecting data, capturing that and processing and analyzing, fast data is all about capturing data as it gets generated. So there is going to be a shift, a slow and steady shift from big data to fast data. And fast data requires tremendous computing power. And there are technologies that are slowly evolving to support this. For example, Apache Kafka, which is an open source high velocity data ingestion service. Apache Spark, which is slowly replacing Apache Hadoop when it comes to real-time processing. And Apache Beam is another technology which is going to let you build real-time ETL pipelines and take care of your real-time analytics. And Apache Kudu is another such open source software designed to deal with real-time fast data-based analytics. And of course, there is Hadoop. So cloud is going to be the home for both fast data and big data. This is going to be a really important transformation in the data platform. So you're going to see how real-time analytics will power our next generation use cases. For example, the moment you swipe your credit card, the bank will be able to find out whether it was a genuine transaction or a fraudulent transaction. And you will be immediately able to authorize the transaction. So today it is done through batch processing, where the bank will call you a week later to check if it was you who actually did the transaction, but not anymore. You are going to get authorized the moment you swipe the card through an OTP, which is going to be pretty instant, and the bank will be able to decide whether it's a fraudulent transaction or a genuine transaction. That's just one of the examples. Finally, the fundamental shift that's going to take place is edge computing, right? So, of course, cloud is where the heavy lifting is going to take place, but lot of applications, lot of use cases, lot of scenarios require a low latency, fast turnaround environment. So what is edge computing? So edge computing is bringing some of the capabilities of cloud right into your data center or right into the edge layer where you typically run your networking gear. So where you run your firewalls, load balancers, switches, routers, and other networking gear is where there will be a lot of computing power made available, and that's where a lot of heavy lifting will also shift into. So in a typical edge computing architecture, you have a set of data sources. Let's call them the first tier. Then you have the second layer, which is going to be the intelligence layer, which is powered by edge computing. And the third layer, where the actual operational insights and analytics take place, that is going to be in the cloud. So very soon we are going to experience the new three-tier architecture, where the first tier is the data, second tier is the intelligence tier, the third one is the analytics and decision-making tier that is going to be on the cloud. So edge computing is a set of commodity hardware devices powered by Intel or ARM processors, and they develop as a networking device as well as a full-blown server. And this server is capable of running some of your machine learning algorithms, perform fast data analytics, do the heavy lifting, which is otherwise done by the cloud, and expose the containers and serverless computing to you so that you can write logic that acts upon the data that is generated in real time. And the edge computing will be intelligent enough to offload the data and the processing to the cloud only when it is required. So this is the evolution of hybrid computing, which is going to be called as edge computing. And companies like Cisco, obviously, who is into the business of creating the networking gear and the data center infrastructure, are investing in the edge computing through their gateways and devices. Dell is also very actively watching this space, and they are going to play a major role in creating edge computing. And all these players are actually responsible for creating a consortium called Open Fog Consortium. So it is also called as fog computing because you have a semi-cloud environment which looks like fog. So edge computing is also called as fog computing, where the responsibility of heavy lifting is shared between cloud and your local edge layer. So they formed what is called as Open Fog Consortium, where the edge computing initiative is being researched, driven, and evangelized by the industry players. So to sum up, the cloud hasn't hit the stagnation. It is still day one for cloud. And I want to borrow this popular saying, now software is eating the world. And I would say open source is eating the cloud, because there is so much of adoption and so much of momentum where open source software is now getting customized and now getting ready to deal with cloud. So we are moving away from cloud being compatible for existing applications to new applications designed exclusively for the cloud. If you go back and look at any of the trends that I touched upon, like blockchain or serverless computing or edge computing and machine learning, all of them are designed keeping cloud in the mind. If cloud doesn't deliver the heavy lifting promise, we wouldn't have any of these technologies. So this is definitely an exciting time, and we are going to see the next generation use cases, scenarios, workloads, and applications driving the adoption of cloud. So this is the most exciting time to be in the industry. If you are interested in any of these trends, those are my coordinates. Feel free to drop me a note, and I'll be happy to have a discussion with you. But if you are in the business of software and if you are a developer, I want you to keep an eye on these evolving trends. They are definitely the next generation technologies and emerging trends in this space. Thank you for this opportunity, and I'm going to come back to you and talk to you more about developing and deploying applications in the cloud post-lunch. Have a great conference ahead. Thank you.